Hello and welcome. Today we're going to be talking about collaborative robots, what they are, how they work, and more importantly, where to use them. Then at the end, I'll give you my thoughts on how they stack up and pay out on the promises made in their marketing. So, let's get started. Now, what is a collaborative robot? A collaborative robot, at its very simplest, is a robot that is intended to work in close proximity to humans and without offense. This is accomplished by using sensors in the arm and feedback data from the motors to let the robot know if it's made contact with an obstacle, namely, a human being. Because these sensors and motors do require some physical resistance before they know they've encountered an obstacle, there's a trade-off, and that is that the robot has to run somewhat slowly. This is because depending on what the robot is carrying and where it contacts a human, it can potentially still do some damage before it actually realizes it's come into contact with a human and makes a complete stop. Along with that, they are usually somewhat limited on payload and reach, as increasing those two things just kind of inherently makes it tougher to make the robot stop really quickly. We're going to talk more about that later, but for now, that pretty much covers the basics of what a collaborative robot is. I should also point out that I will be making a distinction between collaborative robots, as I've just described them, and traditional industrial robots, which are larger, heavier, and pretty much always need a fence. These are the robots that you see putting Terminator together in the movies and stuff, so while they're likely to not take over the world themselves, they'll probably build the robots that do. Now, even though the first collaborative robot was actually introduced around 2004, collaborative robots have really taken off in the marketplace, I would say, kind of over the last 3 to 5 years. A few years ago, if you went to an automation trade show, you might have seen one, maybe two collaborative robot manufacturers. At Automate this year, I think I saw people turning them out of their garages in the parking lot. I mean, there's probably going to be 2 more manufacturers by the time I get this video edited and uploaded. Now, even though collaborative robots are still a very small segment of the overall robot market, and I do mean very small, they are pretty rapidly growing in popularity. But why? Just what is all the hype about? And do they live up to that hype? Well, let's talk about that a bit. There are 4 main things that collaborative robots are really marketed on heavily, and those things seem to be the big reasons that people are attracted to them. The first big thing is the claim that they are easy to program. Collaborative robots made a departure from the kind of button-heavy teach pendants that are common to traditional industrial robots in favor of a more intuitive and slimmed-down user interface. The idea being that they could make robot programming simple enough that one wouldn't necessarily need formal training to program it, or even if you did, it'd be pretty short and sweet. If you ever pick up a teach pendant on a collaborative robot, you're likely to see a flowchart style of programming with function blocks here and there, or maybe even a drag and drop kind of setup for different functions. This doesn't necessarily account for setting up things like devices and sensors and vision systems, though those things are intended to be made much simpler as well. However, it does get the robot moving pretty easily. The second thing, which kind of piggybacks off the first, is the claim that they are easily redeployable. If you factor in ease of programming with not needing a fence, then the idea of redeploying or repurposing a collaborative robot, it starts to look pretty easy. No bunches of equipment to carry around, quick to reprogram for another task. Enough said. The third, and this really is probably the biggest thing, is the claim that they don't need a fence. Collaborative robot manufacturers market pretty heavily on not needing a fence. From my time in integration, and though I've seen some news to the contrary recently, the single biggest reason that I have seen people desire a collaborative robot is the idea that they don't need a fence to operate. Notice that I said idea. More on that later. The fourth and final claim is that they are more cost-effective than traditional industrial robots. This isn't necessarily a function of the actual robot cost itself, because when priced side by side, collaborative robots usually carry a higher price tag than traditional industrial robots. It's actually more of a function of not needing an expensive integrator and the labor costs that would be associated with that integrator doing all the engineering and cell layout and programming and everything. So given all of this, what are some good applications for a collaborative robot? In my opinion, an application that might be suitable for a collaborative robot has to meet at least 3 criteria. It has to be slow-moving, relatively lightweight, and not requiring a high degree of accuracy. Now, these 3 things don't necessarily guarantee a good fit, but it's a good place to start. Some examples would be slow-moving palletizing. For applications where you've got fairly lightweight boxes coming out of conveyors pretty slowly, this is a pretty good application, especially since palletizing doesn't usually require a high degree of accuracy as it is, so it kind of comes together. The same principle can kind of be parlayed into packaging or case filling as long as the speeds and accuracy allow for it. Another similar application is machine tending. Since machine tending cycles are pretty long most of the time, machine tending tends to lend itself to be a good fit for collaborative robots, so long as the parts aren't too heavy. Another one that comes to mind is a dispensing application. Again, so long as the reach and accuracy don't exceed the capabilities of the robot. Lately, I've seen a lot of collaborative welding robots out there, and I'm not sure how this application gets away with being collaborative, honestly, but nobody seems to be blowing a whistle on it, so there you go. So where do you not use a collaborative robot? Well, this is kind of the golden rule. There are no collaborative robots. There are only collaborative applications. I'll say it again. There are no collaborative robots. There are only collaborative applications. Every single application requires a risk assessment to determine if you are using the right tool for the job, as well as any risk mitigation that needs to be put in place for safety. If you put a flamethrower or a chainsaw on the end of a collaborative robot, even though you might be using a collaborative robot, you no longer have a collaborative application. Sure, the robot might recognize when it's run into a human, but unfortunately, that human is going to be missing a limb or be scorched by the time that it does. As such, here's a 3-step elimination process for determining if your application is too dangerous for a collaborative robot. Now, mind you, this is not a replacement for a formal risk assessment, which you should do for any application, nor am I even capable of offering that kind of advice over the internet. This is just a quick and dirty way to check yourself, kind of if you're wondering. First, does it need to move fast? If speed is critical, you're probably going to want a fence. There are things that you can do with safety scanners and light curtains and such, but in my opinion, if you're working in that kind of environment or that kind of case, you're better off just using a traditional industrial robot anyways. Second, is the tool that will be used on the robot hazardous to people? Is it sharp, pointy, pinchy? Does it have any kind of abrasion or material removal capabilities? If that's the case, you'd probably better put a fence around it. Third, and this one gets forgotten a lot, is the object that is being manipulated or carried by the robot hazardous to people? Packaging up Tinker Toys is one thing, but if you're looking for a collaborative robot to pick up scalpels or razors or even flat, sharp sheet metal and put it somewhere, you're probably going to want to put a fence around that. And the same thing goes for something that's either super hot or even super cold. In all of these cases, it doesn't matter how the robot is classified. The actual use of it is what matters. This kind of brings us back to that golden rule. There are no collaborative robots, only collaborative applications. Can't say it enough. So, in summary, how does all of this stack up as an actual use case for collaborative robots? Do they hold up to the claims made by their respective marketing? Are they really all they're cracked up to be? In my opinion, it depends. I know that's kind of a cop-out, but hear me out. My general opinion is that industrial robots are a better investment than collaborative robots, period. Traditional industrial robots are built tougher, last longer, they cost less to maintain, they can run faster and jump higher than collaboratives all day long. You get the idea. Plus, if you kind of look at it like this, and that is that traditional industrial robots are more akin to, the tools that a contractor buys at an industrial supply store compared to the tools that you might buy at your local big box store, professional grade versus consumer grade. They're really just not in the same league, and they're intended for different audiences doing completely different things. The thing with collaborative robots is that they've kind of been marketed as though they can fit into that industrial segment without any kind of a hiccup, and that is not what I've seen be the case. You're just looking at two different animals. Traditional robots are really just made to run all day long for years and years on end. Collaborative robots have followed more of that kind of consumer approach where, you wear it out and you go buy a new one. You don't pay a ton for it up front, even though you do, but you wear it out, you go buy a new one. Industrial robots, I've seen industrial robots out there running for 25 plus years. That's what they're made for. And they haven't been terribly expensive to maintain. And money-wise, I happen to know that you can buy a 200 kg capacity industrial robot cheaper than a 25 kg model from a leading collaborative manufacturer. Yes, you will need to pay more to have it programmed, installed, and integrated, but that system will also last much longer, run much faster, be cheaper to maintain. I'm kind of repeating myself. Also, if you are comparing costs, you have to go beyond the robot and look at how much you're going to pay for peripheral equipment. If you have an assembly application and you need to put a lot of fixtures or, actuators and nut runners and things like that into that application, you're still going to spend a lot of money integrating all that equipment and getting it all to work together. And even then, all that equipment probably isn't going to be collaborative on its own either. You're going to have pinch points and, if you've got servo presses and, actuators and things like that in there, you've already kind of gotten yourself out of the collaborative range and you're going to have to fence it anyways. So you may as well put a heavier duty, longer lasting, faster industrial robot in there and really reap the benefits of that investment. That's my opinion. Now, that all said, there have clearly been cases where people have experienced the marketed advantages of collaborative robots. I go back to the slow speed, non-precise, kind of lighter weight applications. In those cases, I don't see any reason to shy away from a collaborative robot, provided that the risk assessment allows for it. I do believe that these advantages and applications are far more niche than the marketing put forth by most collaborative manufacturers would really have you believe. Collaborative robots can be an effective tool if they are used correctly, but do not mistake them for a true industrial-grade solution, nor a solve-anything robotic solution. Do your homework, talk to an integrator that you trust, and do that risk assessment. Only then will you know what the right tool is for the job. Thanks for watching, and I'll see you next time.